Hey guys, what's up? Welcome to TSK Tutorials, and this is FPS 1.36. Alright, I just want to explain really quickly why there are two versions of FPS 1.36 and why I'm re-uploading this video. So I originally uploaded FPS 1.36, but for some reason it was in 480p and the video was too small to actually read any of the text that was on the screen. So I apologize, and I thank those of you who actually stuck through it and watched the whole fuzzy small video. Thank you. And I am finally uploading the 1080p version, or by the time that you watch this, the 1080p version will be out because that is the video that you are currently watching. Wow, I didn't really need to explain that. But anyways, yes, so YouTube glitched up and now I need to re-upload it, and they said that the video needs to be changed because when I re-uploaded it, it said this is a duplicate video, and I was like, well, no, it's not. This one's in 1080p. And it's functioning perfectly. So apparently I gotta change the video somehow, so that's why I'm adding this little clip in. And I have to re-render it, which takes a long time, so yeah, this has been a pain in the ass, but whatever. So here's the 1080p version of FPS 1.36. So yeah, enjoy the rest of the video. In today's episode, we're going to learn how to randomize the course of the enemy. So in our last episode, we learned how to make the enemy move in a straight line at the player, avoiding obstacles and all that. So today we're going to randomize that up a little bit so that the course that it takes to the player isn't a perfectly straight line and has a little bit of randomized pattern to it to give a little bit more life to the enemy. So this is going to do two things. Well, first of all, it's going to, like I said, add a little bit more life to the enemy and change the way it moves and just keep things changing and random and all that. But it's also going to help when we have multiple enemies, because if we say have like 5 enemies following the player and they're following the exact same path and they all want to go straight at the player, what's going to happen is they're all eventually going to overlap each other and they're all just going to stay on top of each other because they're all following the exact same course. So if we randomize this up, the enemies will be moving around in different directions. They'll take different amounts of time to get to the player, and they won't all be sitting right on top of each other when they're moving at the player. So yeah, let's get started. Alright, so the way that the system is going to work is, first of all, we're creating a custom function that is going to return us a vector3 in world space that is going to be a random position that is inside of the enemy's current cell. And then what we're going to do is basically we're going to have, when the enemy enters a new cell, its first goal is to move towards this randomized vector, and once it's moved towards that, then it will move towards the door. So that way when it enters a room, it'll move to a random place in that room, and then it will move to the next door, creating some randomized movement to the enemy. Alright, so let's take a look at the variables that we're going to be adding to the enemy movement script today. The first one is randomized course, and this is a Boolean true or false variable. So this is going to be a variable that we're going to have at first set to false, or every time we have the enemy enter a new cell, we're going to have this variable equal false. And then once it has moved towards that randomized vector, then it will be set to true, and then once it is set to true, then it will move towards the door. Our next variable is randomized course vector, and this is a vector3, and this is going to be the vector that is going to represent the point in world space that is the random point that is inside of the enemy's current cell. So this is going to be the vector in world space that the enemy is going to move towards, and once it gets close enough to that point, we're going to set randomized course to true, and then the enemy will just move towards the door. Alright, our next variable is calculated new randomized course vector, and this is a Boolean true or false variable. So this is going to be a true and false variable that we're going to switch between true and false depending on whether or not we want to calculate a new vector, because we don't want our game to constantly and randomly be creating new random vectors to move to, because we want the enemy to pick a spot, move towards that spot, and once it gets to that spot, then it will move towards the AI path door. Alright, so let's take a look. First of all, what we're going to be adding inside of function awake, and the only line is randomize course vector equal transform dot position. So at the very start of the game, we're just going to set randomize course vector to equal where the enemy is now. And we're just going to do this just because by default this vector is going to be 0, 0, 0, and most likely that's going to be way across the map, and we don't want the enemy to be moving way across the map to that point for whatever reason. So just to be safe, we're just going to set this to the position of where it is now, because if it tries to get to where it is now, nothing's going to go wrong. It's just going to stay where it is. Alright, now let's take a look at the custom function that we're going to be creating inside of our script, and if you scroll all the way to the bottom, you can see function find random spot in current cell. Alright, so we're going to be creating our own function that we can use inside of this script, or we can actually use it inside of any other script as long as we access it through this script. But in our case, for this function, we're only going to be using it inside of this script. And we can name it whatever we want. I chose to name it find random spot in current cell. And you just need to write it like this, just like you would like right here on trigger function on trigger enter or function update. But you just write the word function, what you want to call it in opening and closing parenthesis, and then in opening and closing brackets, and then the code that you want to be ran or run whenever you call this function. Alright, so the way that we're going to have this function work is that it is only going to have one line of code. It looks like 3 lines of code because it's really long, but it's really one line of code. And it is just going to return us one variable, which is going to be a vector3 variable that is going to represent a point in world space that is a random point inside of the enemy's current cell. So to do this, we simply write the word return space and then whatever variable we want to give it. And in our case, our variable is these 3 long lines right here, which are technically 1 line. But let's say I just wrote the number 6 in the area that I have highlighted right now. Then it would just return us an integer of 6 whenever we write this find random spot in current cell, opening and closing parentheses, anywhere in our code. So when we would write this inside anywhere in our code, basically Unity would just see that as the number 6, or if everything I've highlighted right here were to be replaced with just the number 6. So essentially now the way we have it set up is that whenever we write this in our code, it is going to give us back a new vector3 variable that is going to represent the random point inside of the enemy's current cell. And we're going to use this really long line of code to find that random point. Alright, so one thing about this function is that it's not going to randomize the y value. It is going to keep that flat or consistent with the way that the cube is rotated. So that means that we really need the local y-axis or the transform.up of the AI path cells to be pointing up in world space. Now this means that you can still tilt your cell in any direction that you want, but you just need to know that along the y-axis there's going to be no randomization. So you want that to be pointing upwards. So if you have a staircase, you can have your cell tilted like that and have up be pointing that way. Alright, now let's actually take a look at exactly how we're going to be finding this new vector3. So we're going to be starting off with current cell.transform.position. So we're going to be adding onto this, and right now what I have highlighted, current cell.transform.position, is going to be the very center of that cell. So we're starting at the very center of that cell, so the 0, 0, 0 point of that cell. Alright, now that we have the very center of the current cell, we're going to be adding a vector3 multiplied by a rotation. And all of that is inside of parentheses here. And then, so here's the rotation, which is current cell.transform.rotation, or the rotation of the current cell, and we're going to be multiplying that by this vector3 here. Alright, so let's first take a look at the x-axis of this vector3. So we have random.range. Now random.range is a function inside of the random class that is going to give you a number randomly in between 2 numbers that you give it. So number A and number B. So it'll either give you back number A, number B, or somewhere in between those 2. So let's take a look at how we use it right here. So number A, what we give it is current cell.transform.localscale.x times -0.5. So if you can imagine a cube right now, because we have up here, we're starting with current cell.transform.position, so we're starting in the very center of that cube. We're going to randomly go in between current cell.transform.position.localscale.x times positive 0.5. So here we have 0.00. So negative 0.5 times the local scale will give us a point that is right here on the edge of our cube this way, and then we also times it by positive 0.5. We're going to be over here on the other side of the cube. So now we have two numbers that represent the two edges of the x-axis of that cube, and then when we put those two inside of the random range function, we're going to get a number that is somewhere in between those two numbers. Alright, now on the y-axis, we're going to leave it as 0 because we don't necessarily need the up and down randomization to be randomized, so we're just going to keep that flat so that we're actually finding a random spot within that cube that is actually on a 2D plane within that cube where y just stays at a constant of 0. Alright, now on the z-axis, it is going to be almost the exact same thing as the x-axis, but we just replace the x's with z's because we're going along the z-axis now. So we have current cell.transform.localscale.z times negative 0.5 and current cell.transform.localscale.z times positive 0.5. So we're giving the random range function a number that is going to be in between the back of the cube and the front of the cube. So now we have randomly along the x-axis and the z-axis. So essentially we have a 2D plane within this cube, and we're going to get a random number within that. Alright, so now that we found a random point inside of our cube, now we need to rotate this random point, because the random point has been found as if the cube was not rotated at all and it was perfectly rotated at Euler angles 0, 0, 0. So now if our cube was, or our current cell was rotated, say on a staircase or something like that, we're going to now need to rotate our randomized vector that we found. So to do that, we're simply just going to multiply that vector 3 by current cell.transform.rotation, or the rotation of the current cell. And then when we add all of that to the position of the current cell, now we have our random point that is randomly within inside of the current cell, regardless of how that current cell is rotated. Alright, now that we have our find random spot in current cell function set up, let's take a look at when we're going to be using this function. So if you go to function on trigger enter and then if other.tag equal AI path cell, so whenever our enemy enters into a new cell, we're going to add these two lines of code here, which are randomized course equal false and calculated new randomized course vector equal false. So the reason why we did randomized course equals false, because randomized course basically is asking whether or not the enemy has already moved to a random spot inside of the cell once it has entered a new cell. And since we entered a new cell, the answer to that is obviously no, so we need to set that to false so that the enemy knows to actually go to that new random spot. And then we're going to set calculated new randomized course vector to false, because we want to calculate a new vector based on the new cell that we just entered. Alright, so now let's scroll up here inside of the function update loop, as you can see, and let me find it. Okay, right here we have an if statement that says if calculated new randomized course vector is false. So if that is false, or as we have set down here, if we entered into a new AI path cell, then we are, I am totally lost, where is it? We are going to run these two lines of code here. So that first line of code that we run is randomized course vector. Now remember, this is going to be the vector 3 that is going to save this new random course that we calculated, and we're going to have that equal find random spot in current cell opening and closing parenthesis. So we're calling that function that we created down here. So remember, this is going to return us a vector 3 in world space that is a random point inside of the enemy current cell. And then we're going to save it inside of the variable randomized course vector. And then the next line of code inside of this if statement is calculated new randomized course vector equal true. So you can see right here, these two lines of code are only called if calculated new randomized course vector is false. So we're going to set it to true because we don't need it to calculate a new random vector every frame. We need the enemy to pick a spot and then move towards that spot. And then once it is moved towards that spot, then it will move to the AI path door. Alright, now let's take a look at this if statement right here that we're going to be modifying from our last episode. So in our last episode, it was simply if current cell does not equal player cell, and then we had this line of code here, which made the enemy just move straight towards its goal door or the AI path door. Alright, now let's take a look at the if statement that we made in our last episode, because as you can see, we're going to be modifying it a bit. So in the last episode, it was simply if current cell does not equal player cell, and then it ran this line of code here, which made the enemy move in a straight path straight towards the goal door. Now we only want it to do that if randomized course is true and we have a goal door. And then we're also modifying this if statement to change it to or player cell equal null. So if the player has jumped in the air or is just not touching any of the AI path cells, we want the system to still work and still have the enemies be moving and acting normally. So we're going to run everything, all of these lines of code here. If the enemy is trying to get to the player or simply just doesn't know where the player is. Alright, so we're going to be adding the if statement right here, if randomized course and goal door. So first of all, we're just checking to make sure that we have a goal door for the enemy to move towards. And then we are checking to see if randomized course is true. Now remember, randomized course is only going to be true if the enemy has already moved to a random point inside of the AI path cell once it has entered that cell. So if the enemy has already moved towards that random point, then it is okay for the enemy to move straight at the door. So then if both of these conditions are true, we're just going to run this line of code here, which moves the enemy straight towards the goal door. Alright, now we have an if statement in here, which is if randomized course is false. So if it is false, that means that we had entered into a new cell, and that means that we want the enemy to move to a random point inside of this AI path cell before it moves towards the goal door. So if that is the case, then we're going to run these lines of code here. So the first line of code is going to be the exact same technique that this line of code uses from our last episode. So that is transform.position plus equals randomized course vector minus transform.position dot normalized times current move speed times time.delta time. So we are moving from where the enemy currently is right now, and we are going to be adding to that. And then we have inside of parentheses randomized course vector minus transform.position, essentially turning transform.position into 0.000 and randomized course vector relative to that. So now we have a vector 3 that is pointing from where the enemy is now towards where it wants to go, which is the randomized course vector vector 3 variable. And then we're going to normalize it to give it a magnitude of 1, and then multiply it by current move speed so that our enemy is moving at the speed that we want it to, and then multiplying it by time.delta time to make sure that our enemy is moving at a speed that is consistent with real time and not the number of frames per second that the computer is running at. Alright, now our next line of code is an if statement, which is if vector3.distance transform.position randomized course vector is smaller than transform.localscale.x. So we have vector3.distance, and distance is a function inside of vector3 or inside of the vector3 class, and you give the function distance to vector3s, and then it'll give you the number of units that is the distance between those two vector3s. So essentially right here we are getting a number that represents how far away the enemy is from the randomized course vector. Alright, so now we know the distance between the position of where enemy is now and where it wants to go. And then if that is smaller than transform.localscale.x, then it will run the next few lines of code. Now the reason why we're comparing it against transform.localscale.x is because we don't actually know the scale of what your game is going to be. Your enemy could be 100 units wide, or it could be 0.001 units wide. We don't really know, but we know that the enemy is going to scale and get bigger and smaller with the level, depending on what type of units or measurements or just size of everything that you choose in your game. So because we know that this number is going to scale with the rest of this game, it's a good general number that is going to tell us how far away it is from this point that it wants to get to. So if it is close to that point compared to how big that enemy is, then we will just consider that close enough and just say that the enemy has already gotten to that randomized point, even though really it hasn't exactly gotten to it. It just has gotten close enough to touch it, basically. Alright, now we have two if statements inside of this if statement. Now the first if statement is if goal door. So if we have a goal door that the enemy wants to go to, we're simply going to set randomized course to true so that we know the enemy has already moved to its random point and now it is ready to move towards the door. But if we do not have a goal door, so that means if we either don't know where the player is or if the player is not inside of any of the AI path cells, or if the door that we want to get to is closed because of the animated opening and closing doors, we're just going to stay inside of the cell and continue to randomly move within the cell. So we're going to set calculated new randomized course vector to false, and then when it is set to false, as you can see up here, it's going to find a new randomized course vector. So now if the enemy can't get to the player or doesn't have a goal door, it is just going to stay where it is, and it's just going to randomly keep moving around using the, what did I call it, find random spot in current cell function. Alright, so that's all the code that we're going to be modifying today. So now I'm going to cut the green screen and go into Unity and show you how to do that inside of Unity. Alright, here we are inside of Unity, and now let me demonstrate a problem that we are currently having. So I'm going to duplicate this enemy, and I'm just going to put him in some random spots around the level. I don't know how many we want. I don't know, that should be pretty good right there. Alright, and let me give that a save and run it. And let me show you how these enemies behave when I walk into the cell. So they all are trying to follow me, and their paths tend to overlap a lot, and they all are going to eventually just look like one sphere because they're all going to be overlapping right on top of each other. So that is one thing that the randomization or the path randomization is going to help with. It's going to spread these guys out, and it's not going to look like they're all sitting right on top of each other like that. So let's actually do that. So let's see, I guess we just need to go into the enemy movement script. And oh, whoops, I actually did two takes. This is my second take, and I forgot to delete these lines of code, but these are the variables that we're going to be adding. So we have randomized course, and this is a boolean, and it is by default set to false. Then we have randomized course vector, and this is a vector 3. And then we have calculated new randomized course vector, and this is a boolean. Alright, so let's start off with the function. So, function, and what did we call it? I gotta go over to my text file. Find random spot in current cell. Find random spot, in current cell. Alright. And we are going to be starting off with current cell dot transform dot position plus, and we have some things inside of parentheses, and first of all, current cell dot transform dot rotation, and we're going to be multiplying that by a vector 3. Not 4, 3. There we go. Okay. And there are 3 parts to the vector 3. And let's see, is that the correct number of parentheses? I believe it is. Okay, so first of all, let's start with y, because y is 0 in this case, because we're not moving up and down. And now let's do the x. So first of all, we need random dot range, and the minimum we are going to give it is going to be, what is it? Current cell dot transform dot local scale dot x times negative, can't type, negative 0.5. All right, and we need a closing parenthesis on that. No, wait, not yet. We need the same thing as we have here, but we need to make it multiplied by positive 0.5. So let's just delete that little negative symbol. And now we can put a closing parenthesis. Alright, so that's x and y are done. So let's copy and paste the x and put it in the z. Do I have that right? I feel like I messed it up a little. Yes, I did. I just need to move this parenthesis over here. There we go. And we're just going to change the x's to z's. Okay, and I believe that is everything we need inside of the function. So now every time we call this function, it is going to give us back a random spot that is inside of the enemy's current cell. So now we need to know when to call this function. So we're going to go to, oops, there's a few more lines of code that I forgot to delete. First of all, I have all of this here that I added. So I made a function on trigger stay that is going to act exactly the same as this function on trigger enter. But instead of adding these two lines of code here, it is simply going to set the current cell to the cell that it's in. Actually, I was doing this when I was troubleshooting. I'm not 100% sure that everything right here is 100% necessary. In fact, I'm pretty sure it's going to work without this. But either way, you can go ahead and add that or leave it. Go ahead and experiment however you want. But yes, we're going to be modifying the on trigger enter. Every time we enter a new trigger, and that trigger has a tag of AI path cell, we are going to set the current cell to that game object, and then we're going to set randomized course to false, because that means that randomized course is asking whether or not we have already moved to a random point inside of that cell before moving to the next door. And since we just entered a new cell, the answer to that is no. So we're going to set that to false. And since we entered a new cell, we're going to need to calculate or call this function. So we're going to set calculated new randomized course vector to false. And then up here, we're going to do if calculated new randomized course vector, and if it is false. So I'm going to change that. There we go. So if it is false, we're going to run some lines of code inside of here. And the first one is randomized course vector equal find random spot in current cell. And that's all we need to do there. And then we're just going to set calculated new randomized course vector equal, true, because we just calculated a new one. All right. And now we are going to modify this one, I believe. So first of all, so this is if the enemy is not currently in the same cell as the player and there is a goal door for that enemy to move towards. First of all, I'm going to delete this part and I'm going to change that to or player cell equals null. Lowercase null. So if the player is not inside of the AI path cell area, or the player is jumping or something along that line, then we're going to run everything inside of these brackets here. Okay, and now we need to create an if statement for this one, which is if randomized course. Whoops. Alright, so if we have already randomized our course, then we are going to move towards the door. But if we have not already randomized our course, so if randomized course, how come I can't spell today? Course. And we're going to set that to if it is false. And we're going to put some opening and closing brackets. And first of all, we are going to move towards the random vector. So I'm going to copy and paste this line and put it here, because this line of code that I just copy and pasted will make the enemy move in a straight line towards the goal door. So we're going to simply replace this here, which is the destination that is the goal door, and we're going to change the destination to randomized course vector. Alright, and now we need an if statement in here. If vector3 dot distance transform dot position and randomized course vector is smaller than transform dot local scale dot x. Okay, so basically that was just an if statement that said if we are close to the randomized course vector according to how big our enemy is. So we just have a little bit of room for error there in case the enemy overshoots its goal. It'll just pass over it and be close enough, and it'll just return this as true and say that we have gotten close enough to that vector and move on to the next step. So what do I need next? I think if goal door. So if we have a goal door, we are going to set randomized course to true, because we just randomized our course. But if we don't have a goal door, so if goal door equals null, then we are going to set calculated new randomized course vector to false. That way we calculate a new randomized course vector, and the enemy is just going to move around randomly within inside of the cell, so that the enemy doesn't just stand there and do nothing. It's always moving and always doing something. So I believe that is everything. Why don't we give that a test run and see if there's anything we need to add. I'm thinking there is going to be some things that we need to add, but let's give it a test. So first of all, the enemies are moving nicely on their own just throughout the cells that they're in. Looks pretty nice. They, yeah, well, now let's actually move in here and see how they behave. They're going to start following me. This guy followed me so far. Let's see if the other guy follows me. That guy followed me. Now I need to open this door so that they can follow me all the way. And it looks like they're all following me, and their paths are randomized, and they feel a little bit more alive. These guys are getting stuck in the door a little bit, so I think I need to, let's see, I need to go here, and I need to make this longer. There we go. That was just a problem with the placement of my cells. But now they all seem to be moving pretty well. Now let's see what happens if I jump out. Okay, so I just jumped out, and as you can see, they are flying at me, which is not good. This is very, very glitchy, so let's fix that. We need to go into the player movement script. So where is that? You know, one of these days I really need to just organize all of these. But for now I'm going to be lazy and neglect to do that one more time. Okay, so I'm going to do function on trigger exit. And just whenever we leave a trigger, we're going to set current cell to null because we're not inside of a cell anymore. So now the enemies should know when the player is not inside of a cell, and they won't try to fly at me anymore. So let's give this a test run. They're coming at me alright, and now let's see if I jump out of here. Yes, they don't fly at me anymore, which is good. See, the trick is to make sure that all of the code does not allow the enemies to leave the cells. We want them to stay inside the cells, and if they don't know how to get to the player, well, too bad for the enemy. But we don't want the enemy to fly through walls and fly to get to the player, because that's just very glitchy, and I have another enemy stuck in here. Let's see what the problem is here. Once again, I think I just need to adjust these. Now, one thing that seems to help is to make all of the cells taller. But yes. I'm trying to see if there's any more glitches that we can fix today. I think that's pretty much it. Actually, I wonder if I delete... I'm just going to experiment with one more line of code here. I'm going to... Well, I'm not going to delete this. I'm going to comment it out, which... There we go. Well, I need to add the closing comment. There we go. Okay, so I'm going to delete or comment out the on-trigger stay, and I'm going to see how it behaves now. One thing I need to fix, I need to make this longer because that was too skinny. And then I need to make all of these cells taller because that seems to help to make sure that enemies stay inside of their cells. Actually, with that deleting the on-trigger stay, I actually don't need to make them tall because it only matters when they enter into a new trigger. Okay, so now let's give it a test and see if it's behaving a little better. They're coming at me. It's looking pretty good. They seem to be working perfectly so far. Yes, this is looking very good. I haven't seen any glitches yet. So I guess that on-trigger stay thing is definitely something you want to leave out. They seem to be working better without the on-trigger stay. Have any of them gotten stuck yet? Nope. Nope, this is working very well. This is looking nice. Yep, they all seem to be working pretty well and pretty perfectly. None of them are getting stuck, so that means all my cells are positioned correctly. And yeah, cool. So, I guess that answers that question. So, this part right here, just delete it. It's not worth having because it adds glitches. So, only keep it on the on-trigger enter. So yeah, I think that concludes this episode. So this has been FPS 1.36. Until my next episode, I'll see you guys later, and keep making games.